slope as rate of change. Now, rate of change is defined to be a change of one quantity relative to the change in another quantity. And we know slope is rise over run, where the rise is the change in the y values and the run is the change in the x values. What we have here is just a different way to represent the change in the x and y values. So if I have two y values, say y1 and y2, then the change in those values is the same as the difference between them. If I have two x values, x1 and x2, the change is the same as the difference between them. So if I have 2 points, say x1, y1, and x2, y2, if I subtract the two y values, and then I divide that by the two x values subtracted, then that would give me the slope, or the rate of change. So let's use this formula now in an example. Here I have 2 points P and Q, and I have to use the rate of change formula to find the slope of the line that passes through these points. So I'll start by writing out the formula. Slope is y2 minus y1 divided by x2 minus x1. Now I'm going to label the first point here x1, y1, and the second point x2, y2. So now I just need to fill in the numbers into the formula. So we'll start with y2, which is 1, minus y1, which is here, which is 2. Then I divide that by the x2 value, minus the x1 value, which is 3. Now working this out, I get negative 1 in the numerator, and in the denominator, I get negative 6. Now a negative divided by negative is a positive, so I'm going to rewrite this as 1 over 6. Now if we just look at points P and Q again for a second, you may have noticed that I labeled the first point as x1, y1, but you could have labeled Q as x1, y1, and P as x2, y2. If you use the slope formula using these points, you'll see that you get the same answer. So that is okay. But one thing you can't do is mix up an x1 with a y2. So if you said this was x1 and y2, and this was x2 and a y1, this would be incorrect. You have to keep your x1s with your y1s and your x2s with your y2s. So now let's use the formula again on a different set of points. So I'll label this point x1, y1, and this one here, x2, y2. So now plugging in my y values, I'll get 2 minus 12 in the numerator. Now plugging in my x values, I get 5 minus 1. Now working this out, I get 2 minus 12 to be negative 10, and 5 minus 1 to be 4. Now negative 10 over 4 can be reduced, so let's write this as negative 5 over 2. Now for example 2, we have to identify and correct any errors in Casey's calculation of slope, given points S and T. So if I look at this as x1, y1, and this is x2, y2, I'll follow the formula and see where she went wrong. So the y2 value is 5, that looks fine. The y1 value is 1, and then 5 minus 1 is 4, so the numerator looks correct. Now if I look at the denominator, x2 is not 4. x2 is actually 1, and the x1 is not 1, it should actually be 4. So it looks like these two values here are mixed up. So let's make that note now, that Casey mixed up the numbers in the formula. By putting x1 where x2 should be, and vice versa. So that is an easy fix. Let us now write the correct solution. Slope equals y2 minus y1 over x2 minus x1. Now we said the numerator was fine, so I'll just write that out. And in the denominator, I need to write this as 1 minus 4. So we get 4 in the numerator, but now the denominator becomes a negative 3 as opposed to a positive 3. Now for the last example, we have to identify 2 points on the line and then use these 2 points to find the slope. So this is a nice point and this is a nice point. So writing out the coordinates now, this is negative 5 and negative 1. And this is 0, comma 1. Now I will label my points here and then fill them in. The y2 value is 1 and the y1 value is a negative 1. So I'm going to put that in brackets. The x2 value is 0 and the x1 value is a negative 5. Again, put that in brackets. That's going to be helpful here. 1 minus a negative 1 is the same as 1 plus 1, which is 2. And 0 minus negative 5 works out to be a positive 5. So 2 over 5 is the slope.